Alright, hello everyone. Today we will be going over SQL broadly. We will be kind of going over the syntax of how to create queries and kind of just in general what SQL is about. But before we get started, please everyone go into the description and sign in. I really appreciate it because we can track who's coming and we get a better idea of the interest in these workshops. So yeah. Before we get started, you can download this workbook from our GitHub, which you can see in the top of the screen. We will be using this database, which you can see in the .db file um, right here. Um, that will be kind of our basis what we'll be working off the entire time. Also, you can either work off this through the Python, or you can work off it or use SQL Online IDEs. So either way it works. But yeah, we'll be doing that today. For people in the chat, what is everyone's experience using SQL? Um, no idea to maybe lots of experience. I'd like to get an idea kind of where people are at. And yeah, so we'll probably get a couple minutes, make sure everyone can get in, and then we'll get started. Alright, so let's go ahead and get started. I'll be looking at chat every 5 minutes or so, so if you have a question, feel free to put them in. I'll try to answer them as best as I can and probably as quickly as possible. So really appreciate it if you guys have any chats. I'd like to clear anything up. But let's go ahead and get started. So today we're going over kind of the Scalia database. I think it's about actors, and we'll kind of be going over how to use SQL and be using it in the Python environment. Yeah, so there's many ways you can interact with SQL database. You can do it directly through a terminal, or there's a lot of online browser interfaces nowadays. Um, like for example, Snowflake is a big one right now. They just had their big IPO. You can use Python directly. It's always do it. Today we'll be doing the Python, SQLite, and Pandas kind of workflow, where Python is our coding language, SQLite is our database language, and then Pandas is our like holding data frame. This is a pretty specific way of operating with SQL. There's lots of ways to do it. For example, this summer I did it directly using Apache Spark. So a lot of ways to do it. Just depends on what your company or institution you're working for. First thing is you have to download some stuff. So for example, SQL Alchemy you can download. It's optional I believe nowadays. But one thing I would recommend is using the online browser, especially when you're getting started, because it'll allow you to kind of interact with the database more easily. um, and it can kind of give you more visual aid instead of just simply doing strings of commands like we'll be doing with Python. Um, yeah, so let's go ahead and go into the database. Let me switch my screens. Oops. All right. So here is our database. So if you're on SQL Online, all you do is you go to File, Open SQL, and then you go to that Scala, or how is it? Yeah, Sacula or whatever. I don't know how to say it, but that database, and you open it, and it should open to something like this, where you have all of your tables, or on the left-hand side, and yeah, so we can kind of click through them and see. So if you see the actor table, where we have actor ID, first name, and last update, and yeah, you can kind of see our table. So you have actor table, address table, category, city, country, and so on. And then we have some views which we'll talk about later. So yeah, that's kind of a general idea of our database. We'll get more into it later on. Some things you have to notice though is the names are the columns basically. So if you think of like Excel, those are your columns. The type is kind of like if you think of a call array to Python, like numeric would be like numbers. Varchar would be something like your strings, and timestamps would be a date. For example, a birth date or a time of day or something. I don't know. Not null is kind of what you indicate. So it's a Boolean 0 or 1 value. So not null means this can't be null. So these can't be null. Default value, this means that if no, nothing's assigned, they get one, but these don't have any. So they are, you have to give them a value. And then the last one is primary key. So we'll talk about this one extensively later. But this is very important, and notice that these are very important. Every table has to have some sort of primary key or combination of primary keys. And yeah, you can kind of go through each one and see here the address ID is a primary key, and then you have a bunch of other columns. Don't worry about indexes or triggers. These are something that um, a database administrator or something like that would deal with. This is about increasing the speed of your queries. As a person who's a data analyst, you probably don't have to worry about this unless you're doing some data engineering. And we won't be going into that depth today. Triggers are another thing that are for the data or DBA or database administrators would deal with. These are more so if a certain type of query is made or a certain type of, let's say, update to the database happens, it has some type of update. A good example would be like, say you are adding an address, or let's say you're adding a like city and that city doesn't exist and you're trying to insert it, it'll give you errors like you can't insert it because it's not a real city. Good example. Or maybe it's like a birthday and your birthday it's like, you know, -3. It'll trigger and say, okay, you can't have a negative birthday or birth age. But yeah, so those are some examples, and you see there's a bunch in here, right? Um, yeah, so just any questions? The font size. Okay, yeah. So are you talking about on the I guess I'll do both. I'll increase both. So let me. Alright, I'll increase that font size. Let me increase the font size on my IDE. Alright, how does that look? Is that better? But yeah, so generally how it works. And yeah, I think SQL is any job dealing with data, you're gonna have to use SQL. Almost all data is structured in some type of SQL database, and it's probably still the most popular type of database out there. I know SQL unstructured databases became pretty popular, but they're still you're gonna have to use them. All right, so let's go ahead and get started. So I'll switch back now to the other one. All right, so now that we downloaded or we looked at kind of the database. Um, so yeah, let's learn how we can use SQL. So Python comes with SQLA3, which is just a package, basically allows you to interact um, with a SQL or like a database, for example, the .db file. Oops. Um, and it's pretty straightforward. If you might do this. Another ways you could connect, for example, was maybe there's some online server, like I know in academia, Redcap's a big one. There's a lot of different ways to connect. But yeah, let's just sorry about that. For example, we're using SQLA3 because we actually own the database here. So, what is SQL? I think it's a really good question. It's a structured query language. It's a language of databases. It basically allows you to communicate with a database and tell it what you want from it. Um, it allows you to like manage and store information, access, delete, update, insert. A common thing they call it is CRUD, which is create, read, update, and delete. Allows all those operations, so you can do almost anything. And yeah, so let's go ahead and get started. So this is the um, the database you can see here. So we talked about actor here, and these are kind of all the relationships, right? So actor is related to film actor, which is related to film. Film is related to language. So you can imagine here it's like uh, actor is like Arnold Schwarzenegger. Um, maybe this is I don't know, right? So you can like English, for example, whatever, right? We can imagine the kind of things your address would be like maybe the address of each staff, and these are all these different relationships, right? And we'll kind of go into this deeper, but yeah, generally it's kind of imagine what the database looks like, and it can be pretty messy sometimes. Um, but we'll kind of get into how to fix that. So the first thing you do to connect to any database is we're gonna import SQL3. I've seen also as this SQL3, but we'll just leave it SQL3. Let me make sure it runs. All right, to use module, we would first create a connection to the database. Um, so, do we want to do this? Yeah, sure. Okay, so let me just copy and paste this because I don't remember the exact code. Here you go. So we'll copy and paste this. So all you do, even me, I don't remember the exact syntax. All you do is sqlite.connect, and then you put the database name or a directory to the database. Um, and what this will do is allow you to actually interact with it using this con, right? So now um, we can now like write queries to it. So if we do like SQL underscore query equals, and then we have to use a doc string, which just basically allows you to have um, like longer strings in it. But we could do something like select all. We'll talk about this in a second. From actors, and then do I do this right? Oh, sorry, yeah, sorry. This is the thing I always forget. So you have to do data frame equals. Um, so you use pandas dot read SQL SQL I think query. Sorry guys, I don't remember. And then you put the query in and the connection. SQL query connection, and then you can show the data frame. If it enjoys. Oh, I did misspelled. No? It's not liking me for some reason. There you go. Okay, there's a misspelling here. So that's kind of generally the way you're gonna do it. So you're gonna don't want to talk too much about this syntax yet, but basically all we do is we select all of the rows. This is basically means alls, and then from basically saying what table we're talking about. And then all you do is takes your SQL query and you pass it in with your connection, and it pulls it out for you. Yeah, that's basically how you connect with SQL. I'm actually gonna switch over to back to the online interface. Because I think it's a little more straightforward. If you can basically copy whatever I'm doing, and all you're going to do is replace this with the query, what I'll be showing on the screen. It kind of is the same process over and over again. Yeah, so let's go ahead and get started. We'll first talk about the select and from. So let me switch screens again. Alrighty, so now let's get started talking about syntax. So the main syntax in SQL is a select from where select basically tells you or lets you decide what columns you want to choose. So this is not correct syntax, but it's like the columns. This lets you decide like basically what table you want to choose from, and then this basically is a row-wise row operator, or basically row filter. And I'll explain more what that means, right? But basically, this is the general select from where is a general kind of format of any SQL query, and they get more complex and more simple. So let's start with the most basic one, which we just did, which is select all from, and uh, let's do customer, for example. So let's select all from customer. And then to run it, you just press Shift Enter. Um, you can see it kind of goes in here, right? So as you can see here, when we do this, we get all the rows, or all the rows and all the columns, because we did select all. The star means all the rows, and then database from the database customers, or the table customers. Um, and yeah, so we can kind of see what happens, right? If we change select from, right? So if we change it to just maybe uh, first, I can spell, first name, the last name. We get just the first names and last names. Then we can change this to anything, right? So we can do first name, last name, and then we can do star. And that will do the first name and last name, and then give all the ones again. So we see we have two instances of first and last name. So yeah, basically select. Let's use select which row. It's or select which column. I'm sorry, select the columns. Um, yeah. So let's do so let's just do select all again, and maybe let's try to figure out something we can filter on. So maybe we want to have that we only want active customers, for example. So let's see if there's any inactive customers first. So as we can say where active equals 1, or sorry, 0. So if you notice now is that the where is a filtering on the which rows can be included in our query, and now we can only add where they're non-active, right? So if we want to get only active, we do the inverse, which active equals 1, and then we can filter down again, right? Which is a pretty cool, right? So you can immediately think of all the ways you can apply this. It's not only numbers, we can also say something like where, last, last name equals, let's say, let's do my last name, Frank. Let's see if there's any customers named Frank. Nope, no customer named Frank. Let's do one that we know's in there. Oh, you know what? I think this is an issue of capitalization. So, oops, I need an extra one. Yeah, so we find our one Smith, right? So say we're trying to look up records of someone, we can last name is Smith. Let's see if there's one of Frank, just for my own sake. Whoops, need another one. Nope, no, none named Frank. So in addition to this, we can also chain a multiple where statements together, right? So say we have, let's go back to initial active. So let's make sure that they're active, and then let's also let's do another update. Let's see if they also after so they have to be active and they have to be a customer at store one. So the way they do that is you have these additional commands. So you can do and. So you're adding another command. You can say store ID, let's say equals 1. So now basically you're adding two filterings on the database, right? So your first filtering was that they have to be active, and now they have to have a store ID of 1. Right, so this is pretty cool because you can see that if you wanted some really specific part of your data set, you can use this where to filter down. Um, yeah, so this is kind of a basic idea, and let's say of how it works. So you can do select. Maybe you only want the emails. Um, so you can now you only have the emails of all the people who are active and went to store one. Um, yeah, so that's a good idea. Another way you can see. Um, oh yeah, so I guess we'll stop here for a second. Does anyone have any questions on the select where from? The really basic, where select is filtering on the columns, which columns remain. The from is which data or table you're pulling from. And then the where is filtering on the rows, so basically which ones can still be included. I'll stop for a minute asking a question. See if there's any questions. We can also, if we need, we can do another example, maybe with a different database to keep going. But yeah, so also, you don't have to do it just numerics, right? So if we go back while we wait for questions, um, for example, time is a good one, right? So we have last update, which seems like a time. So you could also say where, you can do time based. So you can say last update is greater than, I don't know what the date range is in here. So like they're about 10. Let's say it's greater than this time. Let's say 10:30 on 11 2011. Let's take this time. So let's say 2011, comma 09, comma 4. base 8, whoops, 18, 10, 30. Why did that not work? Alright, any questions, I guess? But yeah, you can also do it with, you can also filter on times as well. Let's see. Oh, I'm not going to search actually. But yeah, there's you can filter on the times as well. I'm confused why it didn't work. Anyways, yeah, but you can do that as well. So yeah, so that's one. So you can also do. So we talked about and, where you have active equals 1. You can also do ors. So for example, say you want it to be at store 1 or store 2, for example. So you want to be at both either of the stores. You can do where store ID equals 1 or store ID equals 2. So let's look at all the customers who are shopped at store 1 or uh, shopped at store 1 and store 2, and then you can even add chain as well. So you can do and they're not active, let's say. Uh, let's see. So I think you have to do something like this just to make sure. There you go. So yeah, so one reason to add these brackets around these is because basically what it's saying is that I want to be store 1 or store 2 and has to be active. If you don't add this parenthesis here, what it's saying is it has to be store 1 or has to be store 2 and active. I know it may seem similar, but what's saying is that you can be store 1 or it can be has to be active and store 2. So there's a little bit of difference because this is implying it doesn't have to be active or it doesn't have to be non-active. A little different, but yeah, basically you can chain these together. Um, let's see what else we can talk about. Okay, another thing we can talk about is let's say we want to get all the different um, let's say we want all different first names, right? Which might be a relevant question. So we don't want to filter anything. Let's get all like the first names, for example. Um, so you might see is that you might have redundancy in this. So you might have two customers with the exact same name. Let's just see. So another thing you can do is you can do order by first name. Um, no. Okay, let's not do this for example. That's weird. They don't have two first names. But this could be a relevant question, right? So what if there's two customers with the two same first names? You want to have all the first names. What you can do is you can do this select distinct, and basically what this does is it only gets unique um, results. So maybe instead of doing first name, let's do it as store ID. So you can see here is that we only have two store IDs, 1 and 2, and if we remove this, we have lots of repeats. So for example, lots of 1s and 2s. So distinct can be very useful as well. It's another really important command. That's district, not distinct. So distinct, you can also see, for example, if you're doing, okay, let's give another example. Let's go to language, right? So let's go to the language database. So select all. So here we're going to say the language ID and then last update. So these are all different languages, right? Say you just want to get a list of all the different languages, you could do select distinct and then name. And this will get you a distinct name list. I know originally there wasn't, but this would be like an example. So distinct is a very important thing you can add to the select statement. Um, yeah, another thing we can do. Okay, let's do another thing. So let's go back to customers. So back in customers. So say we want to get all the people who are, named Mary. This would be, yet again, we'll use a where. Um, so say, where first name equals Mary. That would only get one customer. What you could also do is you could say where the customer does not equal Mary. So I know typically in some SQL this is different, and in Python it's probably similar as seeing this, but in SQLite it is open close the triangle brackets, and it's going to be all the people with the first name not Mary. And obviously the other things are the same. For example, there's less than or equal to, you know, this one, and less than all that kind of stuff as well. So you can do all those things. Um, yeah. Sorry, as I'm looking through things we should still be talking about. All right, is there any questions? Because then now we're gonna start going to a little more complex stuff. All right, so next thing we're gonna talk about is we're talking about aggregation in SQL. So a good question you might want to ask in SQL is that, okay, how many customers are at store 1 and store 2, right? So when you do this, you could do where store ID equals 1. You can run that query, and then a really lazy way is you could just like do this. But commonly, when you're in a company or a bit large institution, this won't load usually because it'll be on the order of tens of millions, billions, depending on what company you are. I know I was working, it was 70 billion, so it's not gonna load. It's not gonna happen, right? So the way you have to do this is you basically have to count the distinct number of customers, right? Which is customer ID. So what you do is you can say select all. Um, so you can do, if you do select all, sorry, where the store ID equals 1, you can take the count of the customer ID, and basically what that will do, it will count the number of customers um, in each in store 1, right? So you can do the same thing as before. So you can do and active equals 0. Let's say people who are at store 1. So there's 8 people who are at store 1 who are no longer active. So basically, like, this count is called aggregate or aggregator. It basically, as it says, it counts a number of people. It's not simply just listing a combination of rows or just basically a filtering of rows and columns. There's many other ones. So for example, another one is the there's like max, for example. This is a great example. Uh, there's min. Oh, okay, so here's a good example why you don't just count, like scroll down, right? Because we see here that the max customer ID is 592, um, but the actual number of people is 326. So if you just do basically, if you just base it based off the max account ID or customer ID, you'd be wrong by about 200, which is a lot, right? So this count is very important. So like I said, there's max, there's min. Um, there's like sum, for example. So we could like another way we could do it is we could say the sum of um, customer IDs. This is not gonna get. You can say sum of customer IDs divided by. Well, yeah, this does not really make too much sense for this one. Oh, let me try to find an example of would. Payment. Okay, let's do payment, for example. Sum would be a good one for payment. So if we do select, let's go to payment to show off some of the other aggregates. So let's do select all from payment. So you can see here, you can see payment ID, customer ID, staff ID, rental ID, amount, payment date, and last date. So let's see maybe the sum of the amount of things that they paid for, right? So let's say sum of amount. You can see here that we can find the total amount they paid for, so about $67,000. We can also find the average. Um, average. So on average, they paid $4.20 plus some extra noise at the end. We can get again. We can do min and max. Um, min. So their minimum payment is 0, which is kind of strange, but I guess it's, I don't know, volunteering maybe. I don't know. The max is $11, so you can kind of see why it's so skewed so low. Another thing you can do, which is kind of strange, is you don't have to put a column in here, or you can put multiple columns, right? So, for example, if you look back at our original thing, um, for example, payment ID, customer ID, you can all find the max of these, right? So if you do the max of all of them, now that's why I think they're useful, but you can find, why can't I should be able to do that. Why doesn't it like it? Okay, so you can do multiple of those. So you can do max, let's say staff ID, let's say amount. Um, yeah, and you get some weird stuff going on here, but usually you do something like, like max staff ID, max amount. So you can do some weird stuff in SQL. For example, the max staff ID, the max amount. You can change this to all kinds of stuff, right? So these are kind of aggregators. So remember, the aggregators are, average, max, min. I'll do like this. Um, you know, first, last. Oops. Okay. Last. Count sum. Let's see. I'm thinking of any other I'm missing. Yeah, I think those are it. So those are aggregators, right? So if you want to, look at all the columns that you filter down to, this is a good way to do it. Yeah. So yet again, select our basic thing is select from where select is a column, so we can now add aggregator to it to provide new functions or new data types, right? So it's not only just a raw data, now you can sum it. Um, yeah, so another thing we can do is there's a thing called wildcards. Basically, wildcards are you want it to look like something else. So before people get confused, let me explain. So let's go back to the customer from customer. So say we want to find all the people whose first name started with an A. Without wildcards, what you have to do is you think of all the first names possible, and that's borderline impossible because you don't know what people's first names are like. So what you do is you can use wildcards. So what that looks like, you can say from or where first name equals, and you can say it starts with A, and then you do percent sign and close. So the percent sign is what it's saying is it can be any character for any length, but as long as it's similar to this type of um, this type of structure. So it has to be A, and then it can be anything else. One other thing that I should mention. Sorry, let me looking, make sure I'm not missing something. Sorry, one second. Oh yeah, so one other thing you do is you can't use equal. What you use is you have to use like. So basically, instead of saying equal, you have to use like. So when you do this command, you get all the people uh, with first name starting with A, and then we can we can also continue this, right? So Maybe we want people only with names starting with A, B. There's none. Okay, maybe A, M. Yeah, so we get only people with A, M, right? And so also other types of wildcards as well. So another type of wildcard is underscore. So instead of being where the percentage sign is a limited number of characters, it can be anything. Um, it can only be one character. So by that logic, we should only get Amy. And there we go. We only get Amy. Um, yeah, and the other one is the character list. Um, this one, let me go back to this. So character lists, for example, can only be something like, maybe you want to get only people with similar names to Anne or Anna. We can put, for example, I think it's like character list. Uh, Whoops. It's something along those lines. Sorry, I'm forgetting. Something along the lines. I don't use this one very often, but most of the time you're going to use something along these lines. You can also do something like this, where basically their name starts with A and ends with A. They have Angela and Anna, Amanda. So you can do all this kind of stuff. So this is really good with names or strings. You just remember you have to use like and not equals. For example, if you use equals, it doesn't work, right? So like is a really important way. Yeah, so any questions? Um, yeah. So basically, just a reminder is that we have select from where select is we can select which columns of your table you want from, selects which table you're selecting from, and then where is basically doing operations on which rows are included and excluded. You can add aggregators, for example, average, um, which will take the average values or like take over the entire column, take the aggregate of it. You can also do things like wildcards, which will match like regex matching, or basically like it'll match strings to other strings depending on what you do. And yeah, it's kind of a quick overview. Um, yeah. Any questions? I'll stop for a minute and we will keep moving forward. Okay, good question. Of how do we save these outputs, right? So if we're in if we are in Python, right, and we have this, for example, we use a SQL query, then we read the SQL using pandas, and we have this data frame, right? Um, if you're in Python, you can simply, do a command where you can do like, df.save, um, that kind of stuff, right? Or you can like, like write it as a CSV out, right? Um, that's one way. That's one way you can do it. Another way is that if I think it's pretty common practice is that you can just like basically save this query. So, say this is a really large database, say it's on the order of like a terabyte, your query, or maybe it's like, 50 gigs and you don't want to store on a computer. You can simply just save the query each time you want to get the data onto your computer. You can just run the query. Another way to do it, which we won't talk about today, is that you can actually create a new table. So, let me show the screen again. So we have all these tables on our left hand side. What we can actually do is that we can create a query, um, develop a query, and then we can save it to a new table. So basically it's saved on our database, and we can view it easily next time. Yeah, that's kind of like putting it back in your database as a like basically a filtered down table is probably the most compact way because databases are really compact compared to things like CSVs and that kind of stuff, and also you can treat it really fast as well. Um, More generally, um, if you're if you're, you can save it to other types of databases. For example, I sometimes will take SQL databases and save it to, for example, S3 bucket. All kinds of ways you can save it. If you're on SQL Lite right here, I believe you can go like save. I believe there's options somewhere to save it. Nope, that's another tab. Let's see, save. This saves your query. Okay. Oh, sorry. Here, export to CSV. So, say you did a bunch of operations. You found a lot of people. Like here, so say you want to get all the, say you want to get all the sync names, right? First names, right? You get all the distinct first names. You can then save this as a CSV, um, and there you go, right? That's another way you can do it. So there's always save it, depending on your practice, right? Or what you're doing. It's going to depend, but it's kind of, I think, the most common ways. All right. Any other questions? That's a good question. All right. Cool. Okay. So let's go. Let's kind of go back to the Python notebook just to kind of review. Um, yeah. Whoops. So we talked about connecting using Python at the very beginning to connect with the database. This is not required, so this is just one way to do it. Like we said, you can do directly with the SQL terminal. Online, all kinds of ways to do it now. So we won't go too much into that. This is a general structure where you can just copy and paste your queries that we were doing on the web browser in here, and it'll work. Um, and then we talked about select from where, using distinct, using the where clause, the different types of operators, um, using and or to chain multiple different types of where statements together. Uh, and then we talked about the different types of aggregators. Um, talked about wildcards. We talked about order by. We'll review that because I feel like we've skipped it. And then we're going to go into group by right now. Um, yeah, so we'll do group by next, after group by, or after order by. So let me switch screens again. All right, so order by is really important. It's definitely sometimes it's important. So say you want to get these in alphabetical order, but let's say in reverse, so backwards, you can say order by descending first name. Oops, I have to put underscore here. First name is, what does it say? First name is not a, okay, let's make a little, I guess, let's just do from customers. And then we want to say, let's order the customer by first name. So order by first name. And see, okay, so we can order basically by customer's first name. We can also do, you can usually do multiple order bys. So say, for example, you have a tie with first name. I don't think there's any redundancies in here, unfortunately. But you can also do, order by first name, and then you can do by last name. So say if two people are named Aaron, and there's one guy named Aaron Selby and one guy named Aaron Antonio. And make sure you do this. So you can do multiple order bys. I don't think this affects this here. You can also do order by ascending. Uh, why is it not like this? Okay, yeah, so you can do order by ascending or descending. I don't know why it's not liking this all of a sudden. Here you go. So you can do order by, so basically order by ascending or descending is kind of self-explanatory. You can change the ordering from basically first to last or last to first. This is pretty cool sometimes. It's helpful for kind of understanding your data, especially if it's pretty large or you want it to be ordered in a certain way. Say for example you want to order by, I don't know, customer ID, and you want to be something like that. You want to see all the customer IDs. Cool, right? Yeah, so that's another thing you can do. I will note that databases don't care about the ordering of your rows. Um, for example, and what I mean by that is that when it's storing it, it doesn't actually care what order it is. Tables are sets. They're not like matrices. So ordering is sometimes a pretty expensive operation, especially if it's pretty large. So just be careful about that. Usually you don't want to do order by on your initial data set or initial table because it might take a while. Um, yeah, I think it's order by is pretty self-explanatory. You can do order by ascending or descending. You can do order by multiple columns. Um, and yeah, okay, actually I can show you an example of order by store ID. So let's do, we can order by store ID. Um, and then we can also do another order by, let's say customer ID. Oh wait, I have to do it like, whoops. And let's make this descending. There you go. So as you can see here, um, you have customer IDs down ascending order, or sorry, store IDs going down ascending order and customer IDs in a descending order. So that's kind of how you can use two order bys on two different columns. So yeah, that's kind of order by. All right, next thing we'll get into is probably another, or one of the most important things, or probably one of the most important things, is called the group by. So group by is similar to aggregation, is that you're basically gonna take some attribute, group all the people together into some group, and then they're kind of all combined. So I'll give you an example. So say we're gonna group by, let's say, store ID. So you see here that's it's pretty strange. What happened? We should have we basically combined all of the people in store 1 and store 2 together, but you only see people's names. This is just because it takes the first value, but say we take, we combine all the people in store 1 and store 2, and then we take the count of first name, we can get the amount of people in each store. So I'll add another column here. So you can see here in store 1 we have 326 people with the first name, and in store 2 we have 273. So basically what group by does is it takes your database and partitions it based off of this column, the values in it, and then it basically stores all of it within the thing, and then you can do aggregations, right? So you can take yeah. So let's go back to the payment one. I'll give an example. So let's say select. I always do select all from payment just to make sure I'm doing it right. And then let's group by maybe staff ID, right? Let's see if there's um, like if they on average pay different, right? So group by staff ID, right? So this can give you kind of weird results. So let's take the average amount. And then what we can do here is that we have the average amounts, but we can also add the staff ID on the side and the next column over to show which one's doing each. So you can see on average, staff 2 pays a little bit more than staff member 1. You can also do maybe like, the max of the amounts, you know, the min, all that kind of fun stuff. So yeah, they both did the same max, same min. One thing you can't do, however, is that you can't now do something like you can't now put like rental IDs, for example, because okay, so it's gonna be weird, right? Because you shouldn't. Some SQL servers are not allowed to do this, but basically, if we go back, here, you'll see that rental ID, there's a bunch of rental IDs, right? And you shouldn't ever do non-aggregated value when you do group by unless it's the actual thing you're grouping, unless it's the thing you're grouping by, which I'll explain again in a second, because you'll just get the last value, first or last value in it. So when I did this, there's actually multiple values in each group, right? But I'm just getting the last or first value. Um, so it's not really that useful, right? So you have to be careful. Like you may have to make sure these are always aggregates, or it's only the thing you're grouping by. So for example, here I can do staff ID because everything in this column, everything in the group in the staff ID group one has the exact same value, so it's okay to put there. But here, for example, there's different rent IDs within this group, and that's why it's kind of not smart to do non-aggregate values in here. So yeah, it's group by. So you can kind of imagine all the ways you can do this. Um, let's maybe do a different one. Uh, film act. Let's do film actor. We haven't done that one yet. From film. So okay, this one's not the best. Uh, let's see. Store. I don't know, but yeah, there's a lot of good ways to do group by. Group by is really important. Um, maybe let's do group by actor ID. Right, so this will group all the film, this will group all the actors, and we can get the count of the number of films they did by doing, count of film IDs. Basically what it does is it groups, it basically puts all of these actor 1 IDs together, and then it counts how many rows are within it, right? So we should get this. So we get a bunch of different counts of how many films each actor did, and we can add actor ID on the side to see, which actor did how much. So we can see, um, actor 1 did 19 films, actor 2 did 25 films, and so on and so forth. And yeah, so that is kind of group by. And you can also do multiple group bys. For example, you could, group by. Okay, let's go back to this example. So let's do select all. Let's go back to our base from customer, and then let's see. So you could also, we could first group by store, right? Store, and then we could, then we could get the count of the number of people, right? And we could do first name or last name. It doesn't matter. And we can also change order. Let's do store ID. Actually a comma. So you can see here that in store 1 there's 326, and as in store 2 there's 273. Also, one thing I just remember is you can do this as command, and you can basically say you can rename the column. So you can say as, I think it's num people. So then you can say, okay, in store 1 there's 326. So basically the as is just a rename operator, so you can rename your columns. And that's pretty cool. Definitely, if you're going to export this later on, you can have some pretty like nested, for example, SQL aggregators or something like that, and it can be confusing. So you can rename them. But say, for example, we want to group by store ID and by, let's say, if they're active or not, right? So we can do that as well. We need to remove that again. So we can see here is that in store 1 with 0 people, in store 1, sorry, people who are not active in store 1, there's 8 people. In store 1 with that are active is 318. In store 2 with no people active, or sorry, that aren't active, there's 7 people who are active in store 2. There's 266. So you can see how you can kind of chain multiple group bys together to kind of get more distinct information. And you notice again we can use store ID and active in our select statement because they're part of our group by, since they're all the same. And yeah, and also just remember again, we can use as to rename. It's not going to change your query whatsoever. Besides, if you export as CSV or whatever, that column will be different. Any questions on group by? This is probably one of the more important operators you can do in SQL. A lot of times, if you're using like huge data set, like I talked about in the tens of millions or billions, you want to kind of condense it down to more usable data set, maybe onto your computer. You can use group by to maybe, condense customers into segments or that kind of stuff. Definitely pretty interesting. Any other questions? And then I'll move on to kind of the final main topic of joins, which are, I think, last really important thing. All right, we move on. So the last important thing is join. So if you guys remember at the very beginning of this workshop, we talked about primary keys, right? Which you can kind of see here, where we have customer ID. It's our primary key. But basically, primary keys allow us to do is that if you have a primary key of 2 different tables, you can basically zip together tables back together, and so that you can kind of join 2 tables together. So that might be confusing. So let me switch graphics over, and I'll explain. All right, so let's go back to this diagram. Oops. Let's go back to this diagram. So say for example, we want to know, we have a films, but we want to add their language onto it, right? So in the films, it doesn't give us a language, but is connected with a key with the language table, right? So we can use primary as the keys, basically zip them together such that we have all the information in one query. I think this would probably be best explained with a example, but there's, and you have to make sure that the keys match, but it's kind of example. So basically, keys allow you to join 2 tables together without any type of loss or like misaligned rows. And this is very important. And yeah, let's kind of show you how to do that. So let me switch things again. All right, so say we have, so say let's do the example. So let's do select all from, and let's do films, right? So if we do films, we can see here is that we have the title, the description, the release date, the language ID, and so on and so forth, right? But we don't have the English. So language ID, I don't know, is that English? Is that Spanish? Is that French? Is that Mandarin? Is that Japanese? I don't know, right? So it'd be nice if we could use the language, which let me find it. They're alphabetical. Here we go. The language, which, and to zip them back together and basically have another column here that instead of giving the language ID, it gives us, the word for it, for example, English. So here, let me add another one. So let's, if you look at the select all from language, we can see here that language ID represents English 2, 3. So it'd be nice if we can add that back together. So what we can do is we can say select from film, join with language. So basically, we're going to join them together, and then they say, how are we going to zip them together? Which if they do, you have to say on film dot language ID equals language dot language ID. So you can now see Um, that now, one sec, let me try to get rid of this. Uh, there you go. So we can now see that we have the English added on the end. One thing we also notice is that um, we have all of these columns are our initial columns in um, our in the film data or table, and then we add our language table right here, and where the language is the language ID in here, and this language ID in film, language ID and language match. So basically, we can join together, and now we can basically select all from, let's say, the film table, film.star, and then we can also take the language dot name. So as you can see here, I know I'll kind of skip on, but now we have everything kind of conjoined into one table. The dot is basically, so you do the table dot the column name. So here we did all, basically everything in film, and then we did just the language name. So yeah, it's kind of a basic of join. Yeah, it basically allows you to join multiple things together. And you can do multiple joins together, but I won't go into that yet. Another thing we can do is the type of joins. So there are multiple different types of joins, and this will affect your results. So there's inner joins, outer joins, left, and right. So let me try to explain that. Or actually, let me types of SQL joins. I think this probably be great. Okay. So imagine, yeah. So imagine we have our left join, or so left joins are basically we combine all together, and say for example there was a language ID that didn't match over here, we would keep it in the table. So that means that it would just be these values would just be null. Um, our right joins the same thing, opposite. So if there was, for example, not matching on the film side, it would be null. Inner join is basically it only does the intersection of it. And then full join, it does everything. So basically, it combines left, right, and inner join. Basically, it takes the intersection and basically the outsides of it as well. I would honestly most of the time only use I most of the time use inner joins because basically it just finds intersections. So you don't want to have null values really in your data set. There is times you use left and right joins. Say for example, you're trying to find missing data, a left join on might help you. There's times it might be helpful. Outer joins, I've used maybe once or twice. They're not as helpful. Um, I'd mainly focus on inner and left and right joins. And I think by nature, this join is going to be an inner join, I believe. Um, but yeah, any questions? I have a question on Python. Um, I do not get how you run a query in Python. Just put three. Yeah, yeah. So let me go over that really quick. So yeah, so it says how to run a query in Python, right? So we'll go over this again. So go back to the top. So first thing you have to do is we have to create connection, which you do SQL3.connect, and you put the name of your database. Um, and then you create this basically this object called connection. Um, what it does is it allows you the, what it allows you to do is it allows you to connect to your database. So it basically allows you to manipulate it. Then what you do is you create a string or doc string more specifically, which is like you said the three quotation marks, and you can enter your query in that we were doing on the web browser. Basically, so you can basically input what kind of query you want to get, and then actually pull the data out of the database. You use pandas.readSQL, and then the first argument is going to be your doc string that you created, and the second argument is going to be your connection. So basically the object that you create in order to connect to, and then uh, Python's going to do the work for you, and it's going to spit out into this data frame, and then you can then, once you have the data frame, you can then do any type of other manipulations you want to do to it. For example, let's, we can take the thing we just did, it joins, and we can put it right in here. And I'll kind of format it a little better. Right, so we have the select all from films and language.name, and then we join film and language on film.languageid equals language.languageid, and then we can run this whole entire block, and we can see here is that we kind of get this new data frame, right, where we have the name at the end, or the language name at the end, right? You can also do the whole renaming thing again, so you can say as language underscore name. And yeah, you can see your language name, right? And so you can, yeah, that's basically it. Does that explain your question? Awesome, cool. Yeah, so let's go back to the other page. I'm glad I could help. Yeah, so that's kind of joins. So joins are really cool. Let's do another example of joins. Let me pull back up the chart. All right, let me pull back up. Okay, so yet again, let's do another join. So let's do city and country, right? So let's join city and country. So, by nature, with each city, we should know the country. So let's change the. So if we just get the regular, select, we get the entire data or table from what were we doing again? We were doing um, city. Sorry. So we have, the city ID, the city name. It looks like the country ID, um, and then the last update, right? And if we go to the city data or the city table, we can see that the primary key is city ID. And then if we go to country, we can see that the primary key is country ID. So if we want to join these two together, we have to join these two tables together. We have to join on the country ID, right? So if we look at country ID or country, we can see that each country ID is associated with a country name, right? So if we combine these together, so the way we do that is we do select from city join, and let's be more specific to inner join with country on city dot country ID equals country dot country ID. So yeah, then you kind of get it. So yet again, we see we have our, these four columns are traditionally in our study table, but now we added three more columns that we join from our country table, and yeah, so now we can kind of combine these together. So maybe we want to, we don't need the country ID twice. We don't need the last update. Um, so we can do, um, or let's just do this. Let's just get the city ID, the city, and the country and the country ID, right? So let's not do any of the last update. So we can do city, or actually, let's introduce another topic. So another thing we can do um, is instead of doing this city dot city ID, whoops, city dot uh, city ID city dot city, right? Which can feel repetitive, and think for example if you had a really large name, for example, film category, you don't want to type it over and over again. What you can do is we can use this as operator again to kind of make it simple. So we can call a city, we can rename the table city temporarily as A, and we can call the country as B. So basically, rename each table, and then you can kind of reuse it everywhere else. So you can say instead of using city there, you can use A. Instead of country here, you can use B. And then you can you do like a.cityid, and then so you basically can make your life a little bit easier. Um, you can make your life a little easier, right? You don't have to retype things out over and over again. Um, and yeah, that's kind of it. Yet again, you can rename these if you want, however you please. Um, yeah, so that's another cool thing. You can kind of save some time on typing, or if you have a lot of tables, you can start naming them more logical things, especially if you start doing queries on them. That's pretty important. Um, yeah, so you can also specify the joins. You can do inner, left, for example. Um, I don't expect it to change just because I think this is a pretty clean database with like no real nulls in it, so it's not a real issue. Um, but definitely, I would like kind of research different types of joins and how it would affect your data set. Oh, and that's kind of it for joins. I don't want to go too in depth. Um, yeah, so that's kind of it for joins. Any questions before I move on to the very final topic about nested queries, which should be quick? Alright, cool. So let's do the last topic. So last topic is nested SQL queries. So as of so far, we only really talked about basic queries where we have the select from where statements, where we can change the select by aggregating aggregates, for example, average and sum and count to our select. We've augmented the from by doing joins, and we've kind of augmented the where by doing things like and ors with our filters. We're doing things like order bys and joins and group bys and those kind of things, right? But say we want to have a query inside a query. So here's a good example. So say we want to find all of the payments that were at the max price, right? So if we look at just payment, um, there's gonna be multiple payments. We want basically how do you get all the payments at the max price? And say we don't know the max price, for example. Um, what we can do is you can say where, and then you can say amount equals, and then you can start a new query. So let me type this out. So you can say select max amount from payment. So basically what this is doing is this is, as you see, this is a query inside of this query. And what this is doing is that it gets um, the max amount, the max payment amount, and then it basically says, okay, find all the payments that have that max amount. So you have to have no knowledge of the actual amount, but it does it automatically for you. So you can imagine, you can infinitely nest queries together. You can have multiple different types of query structures. Um, for example, you could have a query that makes a table and then you put it in here, for example. So you could have a query that creates all the different maybe types of countries that's filtered down somewhere and you can join on like that. So you can do queries inside of queries, which is pretty cool because it allows you to do a lot more. Um, yeah, and that's kind of, I mean, it's kind of open-ended, but you can do a lot with queries inside of queries. You can do many types of that kind of stuff. It doesn't have to be equals either. It can be, um, you know, greater than or less than, all that kind of stuff. Um, yeah, I'm trying to think of anything else. Um, if you understand the basic queries, you can understand then how to chain them together. That's, I guess, the best way to explain it. Um, yeah, I think that's about it for today. I think I kind of explained the basics of it. If anyone has any questions or now would be a great time to ask. I'd definitely appreciate or enjoy helping anyone out. Um, if not, I think next steps regarding this would be definitely, try to play around with it yourself, either on SQL Online or within Python. I'd definitely try to, try practice some of these yourself. Maybe create some type of analysis problem, or maybe you need to create some queries. Think about how you would do this in SQL instead of just load the entire CSV file or loading the entire thing in and then doing it within Python. Because one thing I will say about SQL is that it's, excuse me, significantly faster than Python. So the reason being is that Python is a single-threaded process, so basically only uses one of your cores at a time, which is really slow. For example, it's not very fast. But when I say SQL is that it's multi-threaded, so it uses as many cores as your computer has. So it's, if you have 4 cores, it's 4 times faster than Python. Another example, or another reason why it's faster is because um, if you notice that SQL is different than most programming language, and SQL is not really even a programming language if you think about it. Most of the time, if you're in programming language like Python, you have to tell the basic programming language what to do and how to do it. Um, but in SQL, you just tell you what you want, which is a little opposite, right? So in Python, you tell how to do it. In SQL, you just tell it what you want. The reason for that is basically some really smart people who developed SQL and a lot of the algorithms behind it basically create all these really optimized ways to figure out how to pull your data the fastest as possible. And it does all these upstream optimizations, so it does it really fast. So basically, my point is that SQL is going to do it faster than Python. And if you're using a really big data set, that prompt's only going to be more noticeable. And in Python, for some operation, it's just it's unreasonable to wait a day for you to basically do a basic filtering where the staff ID is 1, right? Yeah, so definitely SQL is really important. Um, and I think that's really cool. In terms of if you want to learn more, I would definitely look up more syntax about Python. I'll also look up something like relational algebra. It's kind of the backbone of SQL if you want to learn more about the fundamentals of how SQL is kind of created. Um, and yeah, any questions, I guess? I'll look in chat. But yeah, I think SQL um, is really good. I think also if you're undergrad, look for internship at data science or data analyst. Um, they love to see SQL. And if you did a basic project where you're using SQL, that's cool. Um, I think it'd be really helpful. So yeah, that's it. I think I'll save around for a couple more minutes for questions. If you haven't already, please go in the description and sign in so we know that you came. Um, Also, make sure to keep coming to DSI events. So I think next week uh, we will be going, I think, over computer vision. Let's look it up. So if you go to DSI face, you have Facebook, which you can see at the top of the stream if you're watching. I believe next week, uh, so I didn't post it, but I think next week is computer vision, which will be a really cool event. It's more of like a deep learning and computer graphics. So I definitely recommend going out to that. Mitchell's going to do a good job. And that's basically it, I think. Um, I'll wait a couple minutes and then I'll log off. I really appreciate everyone showing up, and yeah, if there's no further questions, I'll probably log off in a minute. Have a good night, guys. That's awesome here. I really appreciate you coming out. I'm happy this helped you. If you need help in the future, feel free to reach out to me. Um, if you need help, I don't have my personal information on here. Um, my name's Simon Frank. You can search me up on LinkedIn and connect with me if you want. I'll actually put my name in chat. Uh, Feel free to connect with me on LinkedIn, and we can, you can ask me questions more about SQL or maybe just about um, data science in general or anything like that. So, help, definitely appreciate it. I always like reaching out to people and helping them succeed. So, Yep. Have a good night. Alright guys, that's gonna be it for me today. If you have any further questions, you can always message me on LinkedIn. Um, I'd love to connect and talk more. But if not, it's gonna be the end of it tonight. If you want to replay this will be published on YouTube sometime later tonight, depending on how fast the internet is, um, and YouTube servers as well. But yeah, that's it for tonight, guys. Look out for our next event next Monday. Um, yeah, have a good night.